Thanks, Sandra. I'm Simon Bolster. I'm the Managing Director, co-founder of Portable PPB, here to talk about what I got excited about 9 years ago when I was here at PDAC. Stepping back before that, about 15 years ago, I was part of the Chiefs group in Newmont, and we brainstormed and said, what could change the industry? What would make a big difference to explorers? And at that stage, we just started using the handheld XRF, and I reported into the chief geochemist, and I said, we talked about if you could do a kilometre-deep hole in a day, that would change the industry. And I said, if we could do low-level gold by portable XRF, that would change the industry. Imagine if you can collect a sample and know what the gold concentration is whilst you're out there in the field or at the camp without shipping samples away to the lab. That would change the industry. And I was here at PDAC, and I was at Wines of the World on the second bottle of wine just after midnight, and someone let slip that CSIRO was experimenting with something like this and probably had a method that could get down to 10 parts per billion. Wow, that's the holy grail. And that's what changed my life away from being a consulting geochemist and having been an exploration manager as well into forming Portable PPB, approaching CSIRO, securing the technology out of CSIRO. And with that intro, I will now launch into to explain how it's possible to do low-level gold by Portable PPB, by PXRF rather, and change the way in which you explore, and even mine. So traditionally exploration, you go and collect samples and you ship them away to the lab. Exploration is all a hypothesis. I think there's something there. I work with a geophysicist. I like to remind them that we're looking for elements off the periodic table. Whilst your geophysics is great, we need elements to confirm whether we found that commodity or whether we've got the pathfinders there. So let's use some chemistry. And of course, you ship the results away, you collect samples, you then gather them up, wait till you've got a batch, you send them away. If it's bust phase, then you can get quick turnaround. During boom phase, you're waiting a long time. I've waited up to 6 months in the past for results. It's very frustrating. So instead, the method to get low-level gold is as simple as having a pouch like this, in which there's a collector. And we're going to put a sample in here. We're going to add a reagent. The one we add is non-toxic, non-hazardous, environmentally friendly. We're going to leach the metal out, and then we're going to read that with the portable XRF. And by doing that, we can get very low concentration. We need to do a certain amount of measurements and things to do it. And I'll just quickly take you through how it runs. So you'd have your samples. You might split them out. The finer the sample, the better it is. We've written a software program, which we call PLIMS, which is Portable Lab Information Management System. You bring your sample numbers in, either manually type them in, or you bring it in as a spreadsheet. You're using barcoding to link your field number to this collector device. We're going to record the weight of the sample, so we can do a weight correction for the mass of the sample. So we tear the scales first. We then put the sample in. As long as it's fine, it's going to work. Anything less than minus 2, minus 3 mils, the finer it is, the better it is. The weight, the scales are connected into our software. We add the reagent. The reagent's non-toxic, non-hazardous, environmentally friendly. Comes as dried powder, reconstitute on site using water, any water that we can drink or animals can drink. We then add that into the sample. Essentially what we're doing is a BLEG sample, bulk leach extractable gold, with a PXRF finish. So then put it in a mixer. This is an earlier version of ours. It looks like a 44-gallon drum because it is. And in there we put the tubes. The new one's much nicer with more pouch-shaped ones. Runs on electric timer. It can all run on solar power. We're 1/90th the energy of a fire assay and 1/46th that of a photon assay. The collector then gets taken out. It gets rinsed. We want to take out roots and the such like, or bits of sand. We then need to dry it, just take the water off, because that's going to affect the XRF signal, and then it's read on an XRF. This is a manual read in this case, or we built automated systems as well. And our software then takes control of the XRF and does the readings. And it also manages all the QA/QC process as well. And by doing that, that's how you can get low-level results out in the field. All designed for a technician we call Fred, or I call Fred, He's the guy we've all worked with, never the brightest at school, likes to have a beer at night, so can be a bit fuzzy-headed. Number dyslexic, so that's where the barcoding comes in. Likes to watch the footy, the ice hockey, or whatever the sport is, or go and visit his girlfriend. Any one of those can lead to a shortcut or a mistake. And we built a system that's intended for a technician to run. It's not your geologist or your geochemist. And it's all about getting fast results so you can move a project forward. So what we have then is we have hardware to run that process, to be able to do the mixing and weighing out the samples. I often get asked what the costs are. I'm just going to run that through now so it takes that question mark away from your minds. So we have hardware, we have consumables with packs of consumables, we have the software, a robotic XRF reading system, and we're now building sea container type setups that can be deployed anywhere and be used for grade control on mine sites or resource drill outs. The hardware kits range from as little as about 3,500 US up to 9,000 US. Consumables start at $9 US, but come down. We've been selling by the sea container load, and people buying sea container loads of consumables are not paying $9, they're paying less than that. We have software, which currently we don't charge for. We have a robotic XRF reading system. There's one up on our booth at 6125 upstairs. They're 35,000 US, comes with a barcode scanner and automates the readings. And then we have container labs, and the container labs depends on the configuration, but they come with solar power and Starlink and servers in them and everything. And air conditioning, they're a great environment. I was in one last week, and Steve Russell and his team do a fantastic job building those and designing them. We've got a lot of companies using us now. So we've got gold majors and miners and juniors. We're in the product guides of some of the labs and some of the big labs using us. We've had great help from the PXRF companies and a whole range of others. And we have a distribution network as well. So far we've led to 3 gold discoveries. We've had 18 stock exchange releases have been made. We're on over 90 sites around the world, so from that early germination within CSIRO, one of the ones that CSIRO wanted us to do was to get this out to the world, and as of today we've exported to 38 countries in 3.5 years since we launched, which I'm particularly proud of, and then building up a network of people to help us as well with that. And the reason why it's taking off is because of this ability to collect a sample, get the results, and then know where to go and do the work the next day. Collect a sample on Monday, results on Tuesday, Wednesday, you're back out in the field. You can follow up along lines and between lines. You can then start making sharp targets. We've got a company in New Zealand that's been sampling down to 5-metre intervals on their last 30 metres. They want to be able to plant the drill rig right on top of the target. And then you test off the drill rig. So if you, instead of doing a big traverse of drill traverse, if you think it's a hole, you've got holes 1 to 8, and you think the source might be at hole 4, drill hole number 4 first and sample off that. If it's not there, move to hole 3 or hole 5. Move the rig around. Be reactive. Change what you're doing. So it's more than just a rapid gold result. It's about changing a whole workflow. The rockbot that we built is about trying to take the pain point out of it, gather more data. As I say, it's got a built-in barcode reader. You can do all your conventional readings with the XRF, with the PXRF. This is just one of the brands. There's SciAps on this unit, but Evident ones as well. Fantastic instruments. When I was an exploration manager, we bought 2, tens of thousands of samples a year. We were running with those, and that gave me fast answers. The missing one was always gold. So awesome now to be able to get gold in it. And we had great feedback. It was like having an extra fieldy on site without the need to feed them with feedback I had. Fieldy's a technician in Australian. We've been working across all the manufacturers, but so far our main methods are on the Evident instruments and the SciAps instruments. And the problems that traditionally that the XRF has for gold, and why I was told that, forget it, Simon, the physics is wrong and the chemistry is wrong, the main problems are you point and shoot, the window on the XRF is pretty small, so unless you're on top of the gold, you won't detect it, but then you get interfering elements. Tungsten being the main one. Tungsten and gold are the same response. Tungsten occurs naturally in orogenic gold systems, but you also end up, if you're drilling and you've got drill samples, you'd be getting tungsten off the tungsten carbide drill bits. So you'll get a false positive. If you've got a lot of arsenic or selenium, they give you false positives, and lead and zinc will be others. And then the detection limits, best detection limits, around about the 3 parts per million. We mine in parts per million, but we find with parts per billion. So you need those very low levels instead. So those have been the problems in the past. We've got QA/QC as the heart of what we do, and we have our LIMS system builds in that QA/QC. We calibrate the XRFs, we check the calibrations throughout the readings, and we also use Aureus standards to check and see that the leach and collect processes worked effectively. And it's through this then that's given the confidence to competent people, the CPs that sign off on stock exchange releases, and hence why we've had 18 stock exchange releases. We've got an online learning management system. It's a bit like a mine induction, series of videos and printed materials linked with AI. So it's in 243 languages. So you can go from English to Spanish to French to Farsi to Swahili, all in, like that. Just flick across, and then the captions on the videos are all in those other languages. So that's a good way to go. There are things that are going to affect the leach process and the collection process. Things like sample sizes, the weight correction will make a difference. There are these variables, we know what those variables are. If the ore is refractory, of course our leach isn't going to work well on that. But again, it comes down to doing some checks. And I'll just point out that we're not a total assay method. We're not like photon, we're not like fire assay. Don't think of it that way. We do focus on high precision. Labs focus on high precision and high accuracy. We focus on high precision, but it's all about fit for purpose answers. It's about having the ability to make quick decisions. And anyone who gets caught up in the precision and accuracy, I always like to remind them that if you're dealing with a soil, it makes a big difference if you collect the soil here or over here. If you collect the soil at that depth or that depth, you're going to get a variance. So don't get too caught up. If you can get an answer today, if you can sample today, get the answer tomorrow, there's gold there. The beauty is you can go back on, Monday sample, Tuesday result, Wednesday go back and do infill around it. If you're still getting gold there, there's gold there. You don't need to worry about the assay too much, yeah? You found what you went there looking for. You discovered what you went looking for. But we can get really good accuracy and precision if we use the right sample prep. And these are geostat standards. This was a happy day for me as co-founder MD to get this data back from our research team that's showing 0.99 correlation on geostat standards from 10 ppb to 100 ppm. The highest assay we've had was sent to us we did blind trials, and we had a blind trial from one of the major labs, and they sent us samples that they were right out to 260 ppm and 220 rather, and we got 252 ppm for the 260, and we got 218 for the 220 ppm. But we're getting these good correlations right down to these low levels, down to 10 ppb. We've tested during the research phase over 30,000 samples from when we took our process out of CSIRO. And we've tested a whole range of mineralizations. Some of the high sulfide gold mineralization can cause problems. Refractory ore causes problems. But that quickly, one, you can smell it and you know it's mineralized. So we always recommend if you think it's mineralized, send it into the lab and get a check. Big samples are always better than little ones as well, as will be made very clear in the next talk. So we're not a silver bullet. Don't believe in silver bullets in exploration. We're definitely not a silver bullet, but it's got its place. Significantly has its place. And as I say, we're about trying to change the workflow. And the traditional workflow, and I've worked for Newmont and others, as I said, you often have a lot of targets on a property, and I've sat in those meetings or participated in the meetings where the brains trust get together and go, right, this year we're going to test targets 1 to 3. So then you set about, and we've got to make sure by the end of that target we've got our drill targets lined up. So then you come through and you do something like that, and you go, yeah, great, we've got our targets, which hopefully we can test before the end of the field season. That's the traditional way, and it's so an alternative way is when you're getting rapid results, sample all your targets. If you think it's good, work out where in the landscape plus or something like that, landform regolith context, work out where low-cost sampling like soils are going to work, place those sample lines over where the best chance of near-surface chemistry is going to be testing the rocks underneath, check along the way, and lo and behold, when you get rapid results, say in the first month you've tested 10 prospects, and we've done where we've tested 12 in a week. Find out where then you're getting anomalous hits for gold. It could be pathfinders as well. And then come back and infill on those zones. That way then you completely change the workflow. You're collecting, measuring and reacting to the results. You're moving the project forward rapidly. You're confirming whether there's gold there or not, if that's your commodity. And ultimately then, instead of doing this one where you're relying greatly on luck, you're quickly homing in on the source and quickly reducing your chance of walking away from a property, or having, worse still, is getting the property killed, the project killed because you've run out of timelines. You get 3 years in majors normally. If you haven't found it in that time, tough luck, another new shiny objects come in and you have to go to the next project. It's happened to me way too often. So what sort of applications? We can cover the whole range from early stage exploration through to grade control. We're doing drill samples and soils, and I'll just take you through this quickly. Our detection limits will vary depending on the mass of the sample. There's a limitation with the PXRF. So if it's a 100-gram sample, it's about a 30 ppb. If it's 250 gram, it's about 12. The bigger the sample, the lower the detection limit. Our results also vary depending on how long we leach and collect the gold for. So the longer we leach it, eventually we've leached and collected all the gold. We initially report out in what we call a detector unit, which means leached and collected gold in parts per billion. When you have enough total assays, you can do a regression and a forward calculation. And this is just to show you from grade control samples, which were only sieved to -2 millimeters, and then leached and collected, and this was done some time ago. This is a visual then that you can then put into Excel, do a regression, forward calculate as if its total amount of gold has been leached and collected. And this is a visual plot then that shows the comparison. The red line there is the detector value, which is the PXRF gold versus fire assay. And you see the match. This data was actually put into SERPAC and used for a resource estimate, and the difference in grade was 1%, the difference in contained ounces was 2%. We were told that when the bench was mined, the calculation from the detector value was closer to the recovered gold than the fire assay value. And it's probably because we're using a big sample as opposed to a 30 gram or 50 gram fire assay. And these were only sieved to -2 mil to do that. Quite remarkable. This one here was 6 days. We were given a plot of land and told to come back in 6 days and show what we found. That's what we did in 6 days. It's our infill along lines and between lines. If you're waiting 7 weeks, this would take 8 months traditionally. It's all done in 1 week. And this is what this company has done up in the Pilbara in Australia. They've come through structural target with an astro image underneath, started sampling here as they started picking up the gold. They came back and did infill. They sent a check assay to the lab. They reported these results to the ASX. They then went drilling, and the second drill hole was 41 at 2.37. They were able to walk the ground, look at the rocks, and sight the drill hole whilst doing that first round of work. Brought their discovery forward by over a year. Time is money. RC samples, what we're doing is we don't bother pulverizing. The hammer's done that effectively. It's spitting out pulped material, chips and fragments. So why not just sieve it? Discard the chips and fragments that are not going to leach well, focus on the fines, put those in the pouch, leach and collect off that. If we sieve to -1 mil, we're getting 0.95 correlation with fire assay. Quick, simple, know the answer, know where to keep drilling, where to move on elsewhere. And we had a company in South Australia do exactly that. There's a video where they talk about this. They're saving 70% on their lab assays, and they're also moving the rig around based on the assays. They were drilling 3D seismic targets, which are out under cover, under regolith. Went to the first prospect where they thought the decent structure was, drilled on that, found it was dry, didn't contain gold, moved to the second prospect, dry, not enough gold, went to the third prospect, kept on rolling the meters from one target to the next meter to the next one, held on to the drill rig, and then that's led on to the Toma discovery. They also picked up silver as well on the bench. Diamond core, clearly can't be putting sticks of core into these pouches. So what we do is when the core is cut, we take the sludge that comes off the core saw. If you use Australia we call it a brick saw, here it's a tile saw. Use the tile saw. Metre of NQ core gives about 230 grams of dried sediment. Quite surprising, first time I did it. They used to do it back in the 60s and 70s apparently. I thought it was new and novel, but it's not. And then by doing this, company in Zimbabwe has done exactly this. This is their setup. They even made up their own drum. They release these results to the London Stock Exchange, and it's a comparison between detector gold and fire assay. And there we are. There's the slot that's been cut. There's a Bay Marie tray, stainless steel catering tray out the back, and they capture the sediment in that. They don't dry the sediment. We just drip dry it, put it in the pouch, leach and collect off that. And by doing that, then you can make a decision about, one, identify where there is mineralisation in the core, and then you've got a chance then, whilst the rig is still parked over the collar, to get another piercing or two piercing off that one collar, put a wedge in and get another piercing in without taking the rig away, get the assays back, bring the rig back in again, re-enter the hole with all that machine time. So again, fast decisions. And in this one here, they told me that visually they can't tell where the gold is because there's speckled sulfides all the way through that unit, but we've absolutely nailed. Detector has found the same as the fire assay. So it works. And ultimately then, by doing these processes and systems, it's all about how do we move quickly from a conceptual geological target, identify the anomalies, come through and drill them, and then take it up the pyramid. Currently it's 18 years from first discovery hole to first gold bar on average. What we're about is compressing time and doing that very effectively. The companies adopting us are doing that very effectively. And we're building systems from pelican case through to sea containers. So cover off on that full gamut. I'll just show you a quick case study that sort of pulls it all together. What I found is that I can tell the difference these days between a lifestyle company and a true explorer. And it usually goes along the lines of, oh, we got this method for PXRF gold. And I asked them whether they have a portable XRF. And true explorers generally have them because they already recognise the value of them. And the other discussion then that comes on is, if it's a lifestyle company, it tends to be, oh, it's $45,000 or $50,000 for an XRF. Well, that's a bit expensive. Whereas the new explorers, the real discoverers, they're awesome, aren't they? You can use it for this and that. You're telling me now you can get gold on it. Wow, let's go. And for those who haven't fully appreciated the value of the XRF, one of them, it's a bit of a pain sometimes to do the readings, which is why we built our RockBot system. It could be 60 seconds or 90 seconds per reading. It's just enough time to line up the next sample. By automating it, we've sped up that process. And our RockBot then can automate the reading of the collectors, or we can do 4-micron proper XRF caps, all with barcoding, or a quick and dirty XRF reading through a bag. This is where the pulps could be put into. You could be sieving next door to a drill rig or collecting soils, come back. Fred Fred's number dyslexia is covered off with barcoding on everything. Lay it out and then leave it to run. And I just want to show you an example quickly from Western Australia where the pulps were put into the bags and it's under a paleo channel with deep weathering underneath it with a big regolith cover. Regolith being everything from fresh rock to fresh air. Some of that then can be weathered rock as well as transported material. And then they've been put in here as well as running it for gold. Here's a cross-section which comprises of air core, RC and deep diamond holes. Quick comparison there between detector gold values versus fire assay from this section. And here you can see the numbers are very similar. And we've, in 6 hours, and this was 6-hour data, we've leached and extracted nearly 95% of the gold, sometimes a little bit higher. But deeper in the profile down here, again, no problems telling where the gold is. But this time we're only getting about 60% recoveries. If we ran the process for longer, these numbers would get larger. But it served the purpose of identifying where there's gold, make that decision to move forward with the program. As I said, the XRF is a brilliant tool for identifying, by doing a conventional reading, you'll get 30 plus elements that can be very useful. And here's where we've taken the XRF readings from those pulps and then put it into iogas using, and looking here at titanium, zirconium, niobium, yttrium. This is a Winchester-Floyd plot. And then dividing out, this data was processed by Simon Griffiths, not by us. Simon used to be chief geochemist at Barrick, amongst other companies. He's pulled out overburden, different types of greenstones, and then some other units. And it's fine to have it like this, but let's have a look at it spatially. So I'm glad to say that the overburden is at the top of the hole, but look how well it's mapping the geology. This is the power of the portable XRF, the starting point for it. Cheap data that Fred can collect. Using Rockbot, it automates that process. And you've eliminated that thing of 1 rock, 5 geologists, 6 names for the rock. You've got objective logging. Then you can look at weathering. Again, PXRF data using calcium, iron and sulfur. This is blade refusal air core where the bottom meters are showing up as unweathered. It works. And by doing this then we're putting in base of transported. We've now got some geotech data. We're also showing that in the deeply weathered profile, the original one might be that it could be deep overburden, but in reality it's quite shallow. Because clearly we've got the same residual elements as deep down, which aren't weathered, titanium, zirconium, niobium, yttrium, resist dates, and they've stayed in the profile. So clearly even in the weathering zone, which could be a clay, it's residual. Now let's look at the gold. This is gold from detector, and it's showing it now in 2 units. And interestingly, there's a concentration here at the base of the weathering zone, which is supergene gold that's lighting up. And then a comparison between the lab results and our detector results. We found the gold in the same place each and every time. And we can then look at other elements, like here's arsenic. Arsenic's going with the gold. Arsenic's clearly a pathfinder element. Again, all from the PXRF. And we can look at sulfur. And interestingly here, the sulfur is there until you hit the base of weathering. And that's because the pyrite is weathered out. And now when you look at all this together, we've had gold results near the top where we got 95% recovery. That's in the oxide zone. Interestingly, there's no sulfides there. Whereas deeper in the profile, where we got 60% recover, that corresponds with the arsenic and sulfur, arsenopyrite, suggesting then you've got refractory gold caught up in the arsenopyrite with free gold that's been leached. So you're identifying 2 different geomet environments, all done from the PXRF, or easy to collect data that costs a few dollars a time for the multi-element data. So for those who think that the barrier for entry for using detector is the cost of the PXRF, think of it for all this other data you can collect. So the sorts of places where it's being run now is out in garages like this, and this is where the Tolma discovery was made. Silver was picked up on the rock bot that was being run here. But by doing this, the guys are saving nearly 70% on their lab assays. They could be run out here in, as it has been up in Nunavut, up near Hope Bay, in a tent, back of a trailer out near Kalgoorlie, or in a core shed in Senegal, in West Africa. We've designed, all through Block 10, which is now part of Portable PPB, designing container labs and sample prep labs, and the designs are now turning into reality and going out to sites. This is out in Menzies, north of Kalgoorlie, as part of the field trials going on at the moment. And inside it, the container has solar panels on it. It's got Starlink in there, a server in there, communicating back up to AWS to quickly disseminate the assays and get them back into the hands of the explorers or the miners. And well set up with rock bottom there, and dust benches and mixers and everything needed to be able to get assays and comfort for high throughputs. And then we're also building, or have the ability as well, to supply things like mini crushers and pulverizers, and splitting systems. There's also pellets for doing compressed pellets for spectral or LIPS reasons as well. So all part of Portable PPB, and Steve Russell is in the room responsible for those. We're also doing other elements like silver. Bit experimental at this stage, but the orange line or brownie colour looking line here is lab silver. -1 mil sieving, we only extract a bit of the gold silver, but once we've pulped it and ran it, we get almost identical to lab silver. And silver is an awesome pathfinder for gold, as well as being a commodity of interest in its own right, as it is today, up around $90 per ounce. So today, from the chat in the pub up the road here at the Royal York, we're 30 staff. We've got a factory. We're exporting to the world. We've got a company here in Canada. We've got stock in a warehouse in Canada, so it's easy to get it into this part of the world. And we're air freighting and shipping all over the world now. As I said, it's 38 countries, and we're 30 plus staff, which includes software engineers, chemical research chemists, geochemists, mechatronics engineers, as well as a full support team as well. And that's some of them. And at the end of the day, it's all about saving time, rewarding shareholders. The faster you can make a discovery, the better it is for everyone. I usually say, look, remember, it shouldn't be competition between Barrick and Newmont, or Rio and BHP. Remember, we're also in competition between crypto and marijuana and banks and telcos. We need to make this industry more efficient and effective. And the best way to do that is to show that we're a really good way to invest that can deliver real returns to shareholders. And the best way to do that is to make discoveries and generate real wealth. Don't just go through the motions of exploring, be discoverers and move it on that way. So same day infill gold assays is a reality now. It's with a simple to use, easy to learn process. It's green and clean. It's low capex, low opex to get started. It's proven. It's made 3 gold discoveries so far in the 3 years since launching. We're saving time, money, and enabling that new process of exploring, so it's smarter and faster decision making. And with that, I will end there. Thank you very much.